Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Few attendance is here. Still 41 students have joined. So we will wait for 2 minutes, then we will start. Good morning. Let me take your attendance first, then we will continue our class. Roll number 1. All of you unmute your mic. Roll
Present,
number
ma'am. Roll 1, present, ma'am.
Roll 2.
Present, ma'am.
Roll 3.
Present, ma'am.
Roll 4.
Present, ma'am.
Roll 5. Roll 5. Roll 6.
Present, ma'am.
Roll 7. 8.
Present, ma'am.
9.
Present, ma'am.
10.
Present,
11.
ma'am.
11. 12.
Present, ma'am.
13. 14.
Present, ma'am.
15. 16.
Present, ma'am.
17.
Present, ma'am.
18. 18. 19.
Present, ma'am.
20.
Present, ma'am.
21.
Present, ma'am.
22, 23,
23 present, ma'am.
24, 24, 25, 26, 27,
Yes, ma'am.
28, 29, 30,
Present, ma'am.
31, 32, 33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
38, 39,
Present, ma'am.
40,
Present, ma'am.
41, 42,
Present, ma'am.
43,
Present, ma'am.
44,
Present, ma'am.
45,
Present, ma'am.
46, 47, 48,
Present, ma'am.
49, 50, 51,
Present, ma'am.
52, 53, 54, 55, 56,
Present, ma'am.
57, 58, 59, 60, 61, 62, 63, 64, 65,
Present, ma'am.
66,
Present, ma'am.
67, 68, 69, 70,
70 present, ma'am.
71, 72,
Present, ma'am.
73, 74, 75,
Present, ma'am.
76,
Present, ma'am.
77,
Present, ma'am.
78, 79, 80,
Present, ma'am.
81, 82,
Present, ma'am.
83, 83, 84, 85, 86, 87,
Present, ma'am. 87.
88,
Present, ma'am.
89,
Present, ma'am.
90, 91,
Present, ma'am.
92,
Present, ma'am.
93,
Present, ma'am.
94,
Yes, ma'am.
95,
Present, ma'am.
96, 97, 98, 99, 100,
Present, ma'am.
101,
Present, ma'am.
102,
Present, ma'am.
103,
Present, ma'am.
104,
Present, ma'am. 104.
105,
Present, ma'am.
106, 107,
Present, ma'am.
108, 109,
Present, ma'am.
110, 111,
Present, ma'am.
112,
Present, ma'am.
113,
Present, ma'am.
114, 106, 15,
Present, ma'am.
116,
Present, ma'am.
117, 118,
Present, ma'am.
119,
Present, ma'am.
120,
Present, ma'am.
121,
Present, ma'am.
122.
Present, ma'am.
Okay, so we'll continue from the last class.
Ma'am, 25 should be.
Today
124.
we
Roll number 25, ma'am.
नहीं, जो बाद में अटेंडेंस दे रहा है उसको नहीं. Okay, so last class we were continuing superheater. So superheater we have discussed this diagram. So there we are having the U type superheater. So both the end is closed with the help of the headers. So one side there will be the supply of the wet steam. This is the steam inlet through the headers. So it will take the heat from the flue gases. So here damper is provided so that proper direction of the flue gas will be achieved by the help of this damper. Okay, so by taking the heat from the flue gases, that wet steam will be converted into the superheated steam, so which can be collected at the valve, that is the V2, when it is required. Then here we are having the two valve V1 and V3. So sometimes if it is requirement of the wet steam, then that time this V3 valve will be open, but V2 will be closed. And when your V2 will be supplied, that time V3 will be closed. So this is all about your superheater. So there we are having the two types of superheater. One is the convective superheater, another one is the radiant superheater. As the name is given, convective superheater, so that heat transfer uh, will be the convective process. So these type of superheater will be placed outside of the furnace, and that flue gases will be used to heat that used to increase the temperature of the wet steam. And in case of this radiant superheater, it is placed inside the furnace, and here this type of superheater are used when there is the requirement of the high amount of superheated steam. Okay, so the heat transfer uh, will be the radiant process. Okay, so then we are having the this is the steam separator. So steam separator, why it is required? So sometimes there will be the moisture content in the steam. So to remove that moisture content or water content from the steam, this steam separator are used. So a boiler will provide you different types of steam. So those are your wet, dry, saturated, and superheated steam. Okay. So when this heat, if it is the wet steam, when this wet steam is applied through the pipe, so through the long pipe, what will happen? It may condense through the pipeline when it is reaching to the turbine. So in that case, if that if that steam is condensed, that will stick to the surface of that pipe, or when it is going to the turbine, there that moisture content will stick to the turbine blade. So it may form the some risks to the turbine blade, or there will be the corrosion on the turbine blade. So because of that one, that use of this type of steam will be the uneconomical. So because of that one, we have to use this steam separator before the turbine itself. Okay, so or near to the turbine. So in this case, the steam will remove the entrained water particle which are present in the steam. So if you are observing, this is the one example of the steam separator. So there are the different types of steam separator. So there are the different types of steam separator based upon the principle of the operation. So first one is the impact. Third one is the centrifugal type. Centrifugal type. So there are the three different types of steam separators are used. So first one is the impact or baffle type. So this is the example of your impact baffle type. Okay. So second one is the reverse current type, and third one is the centrifugal type. So this is the impact type of steam separator. So if you are observing in this case, A is the steam inlet, and B are the presence of the baffles. These are the baffles, and so first the steam will enter through this pipe. So 80 baffles that will strike, and that low density of steam will pass through the another tube, that is the C, and then it will go to the directly to the turbine. So if we are observing in this case, here the lower place, there is the presence of the drum, where that water or condensate can be collected at the lower position. So when the steam will strike to the baffle, at that time the high density of water or condensate will be collected at the lower portion through this way. Okay, so then the high quality of steam will be supplied to the turbine. So there will be the presence of the water gauge. So it will check the level of water or condensate form inside the drum, and that will be drained with the help of the drain pipe. So D is the drain pipe. So this is the simple function of the steam separator. It is the baffle type or impact type of steam separator. Okay. So next, we are going to discuss about the feed water heaters. And evaporators. So I will discuss only the part of the only I'll discuss the definition. So I'm not going to details about this one. So feed water heaters means it is required at the inlet of the boiler. So all of you know that the most of the power plant or thermal power plant, they are designed based upon that whatever the condensate are formed, that will be circulated inside the boiler itself. Okay, so what we are doing in case of the boiler, so before entering that feed water which entering to the boiler, that temperature can be increased so that the fuel consumption can be reduced, as well as the efficiency of the boiler will be increased. So the feed water. So when we are heating the when we are heating the feed water with the help of the steam at the lower pressure of the boiler working pressure, in that case, your overall efficiency of the plant will increase, or the boiler efficiency will increase. So this one already we have discussed feed water heaters in case of the regenerative cycle. So in that case, what we are using, the some amount of steam was bleeded from the turbine at the certain uh, at, um, at, at particular place. So that is the function of the steam generator. and that heating of the feed water can be achieved by using the drawing the some amount of steam from the boiler also. So there are the different method of heating the feed water, so that our efficiency of the boiler can be increased. So there is the different types of feed water heaters are available in the market. So as for that one, that feed water heaters are classified as, there are the open or contact type. Second one is the closed or closed or surface type. So this already I have told you in case of the regenerative cycle surface type. So again I'm telling you this one, open or contact type. Here we are having the tray type and jet type. Okay, tray type and jet type. So under this closed surface type, we are considering the heat exchanger type, that is a cell and tube type. Type of heaters, feed water heaters. Okay, so tray type or jet type means, tray type means there will be the open tube will be there, so through which the water will be spread to the drum, so that that will take the heat from the steam, and the temperature will increase, and that water will be collected uh, at the outlet. Okay, so that is the tray type, and jet type means in this case that water will be supplied with the high pressure. So with the help of the high pressure spray, or where your droplet size of water will be decreased. So that droplet of water will take the heat from the steam, and that increased temperature of water will be supplied to the boiler. Okay, so that is the jet type. So if you are observing, it is the open contact type, tray type of feed water heater. So here there will be the supply of the feed water. So this is the tube, spray pipe. Okay, so we can see it is the spray pipe. So over which that water will be sprayed through the heating trace. So this is the heating trace. It is the air removing trace. So from this, the air will be removed from the water, high temperature of water. So here the what kind of so in this case the gases will also removed from the water. So which kind of gases are removed from this air removing trace? Those gases are your O2, CO2, NH3. Okay, so these gases will also remove from the water, so that the good quality of feed water will be supplied to the boiler. So one end the feed water will be supplied to the pipe, and that will be spread to the heating trace. So this one is the steam inlet. So at this place, your feed water temperature will increase, that other gases present in the case of the water that can be removed by air removing trace. So another end there will be the venting of the steam to the other accessories like your economizer and your air preheater. Then there will be the if it is the overflow of water will be there, that will be removed from this position. So this one is the feed water outlet. Okay, so this is the method of heating of the feed water in case of the tray type of feed water heaters. Okay, so jet type, as I have already told you, here it will require the spray or nozzle type of structure with the which will reduce the diameter of the water droplet. So these jet type of feed water heaters are used in case of the marine applications. Okay, so this is all about your open or contact type. Then we are having the closed surface type. So this is the figure of the closed surface type. So here there will be the saline tube type structure. So one end there will be the supply of the water to the drum. So other side there will be the supply of the steam. So here the space are there to, for the supply of the water continuously through this tube. So these are the tubes. So here due to the method of convection, your water temperature will increase. So other end this will that condensate will form, so which will be supplied to the your boiler. Okay, so other end that the left over waters are circulate to the other end of other space, so which will be uh, supplied to the um, your like your artificial pond or lake which are present in the power stations. Okay, so these are the jet type of sorry closed type of feed water heaters or mm, surface feed water heater we can say. So these are the all about your accessories. So what are the accessories? First one is the feed pump, then we have discussed the nozzle, then we have discussed the ERP heater and a super heater, steam separator, economizer, then feed water heater. Last one is the evaporators. So evaporators are used to supply the pure water to the boiler, that is the distilled water. If it is the dissolved gases are present in case of the condensate or water or makeup water, in that case that gases will be removed from that water and the pure water will be supplied to the steam boiler. So that is the function of the evaporator. So I'm not going to the details about it. So next one is your so there are the certain terms which we need to discuss for the boiler efficiency. Or we need to discuss about the performance of the boiler. So performance of the boiler are certainly we are expressing with the evaporating capacity, evaporating or evaporative capacity. Okay, so which can be expressed that is in terms of the uh, kg of steam generated per hour, and sometimes we are expressing kg of steam generated per hour per meter square of heating surface. So how much heating surface you are providing, as per that one your steam will be generated. And third, it can be represented as kg of steam per kg of fuel burn or fire. Okay, or fire. Okay, so evaporating capacity or performance of the boilers are we are expressing in terms of the evaporative capacity, so which can be represented in terms of the kg of steam generated per hour, kg of steam generated per hour per meter squares of the heating surfaces. The third point is the kg of steam generated per kg of fuel burnt or fire. So second one is your equivalent evaporation. So as we all know that there are the different types of boilers are available as per the given working pressure and given temperature. So in that case, the comparison cannot be evaluated based upon the how much amount of water is converted into the steam. So that is not the basis. So in that case, what we are doing, we are considering the equivalent evaporation is one parameter through which your comparison of the boilers can be formed. Okay. So what is that equivalent evaporation? Equivalent evaporation is it is defined as amount of water evaporated from water at 100 degrees Celsius to dry and saturated steam at 100 degree Celsius. So that is known as the equivalent evaporation. Okay. So let us consider that the MA is nothing but it is the amount of steam generated, the amount of steam generated or that boiler is able to generate the MA kg of steam at the particular pressure P and temperature T. Okay, so given saturation temperature pressure, or we can say given saturation pressure and given temperature. Okay, so in that case, the MA is the amount of steam generated, or we can say the amount of water is converted into the steam. That is also known as the MA. Okay, so in this case, let us consider the H is nothing but it is the enthalpy of the steam. Enthalpy of steam generated per kg under given condition. Under given condition means at the given pressure and temperature condition. Okay, so how to represent this H? So this H can be find out by the formula. So H is equal to HF plus HFG. So this formula is valid for which steam? Any one of you?
When x is equals to 1.
Yeah, then X is equal to 1. So that is which steam? Dry saturated. Okay. So in case of the dry saturated steam, X is equal to 1. So we can find out what will be the enthalpy of the steam per kg under the given condition. Okay, so sometimes we are writing H equal to HF plus X HFG. So this equation is valid for
Wet steam.
wet steam. Wet steam, right? So in this case, X is known as
0 to 1 live.
0 to 1.
Dry saturation
X is
factor.
known as your dryness fraction. Okay, so at given condition. Given condition means at given pressure condition or pressure temperature, whatever may be. प्रेशर दिया होगा तो उसी के हिसाब से प्रेशर वेस्ट में आप फाइंड आउट कीजिएगा, टेम्परेचर दिया होगा तो टेम्परेचर वेस्ट में आप लोग फाइंड आउट कीजिएगा. ओके, सो दिस इज फॉर द वेट steam, and x is nothing but it will vary from 0 to 1. Okay, so again we can represent it as h is nothing but it is equal to hf plus hfg plus cp t superheated plus ts. Ts means it is the saturation temperature. So this equation is valid for the superheated steam. Okay, at given pressure P and temperature is your saturation temperature. Okay, so this is the formula generally we are using for the enthalpy of the steam generated per kg under the given condition. So in this case, let us we are considering as the HF1. HF1 is what? It is the specific enthalpy water at given feed water temperature or pump pressure, right? Okay, so if we are considering HF1, in that case, the heat gained by the steam will be how much? Heat gained by the steam from boiler per unit time. Per unit time can be represented as MA H minus HF1. Okay, so this heat gained by the steam from boiler per unit time can be also we can also uh, defined as it is the how much amount of water is converted to the steam by absorbing the energy, that is the absorbing the heat. So how much energy is absorbed to convert that water into the steam, or it can be written as heat gained by the steam from boiler per unit time. So by using this formula, we can write as equivalent evaporation will be how much? So as I have already told you, it is the equivalent evaporation is defined as your amount of water evaporated from water at 100 degrees Celsius to dry and saturated steam at 100 degrees Celsius. So that is nothing but it is the heat gained by the steam, that is the MA H minus HF1 upon your HFG. So if you are converting the 1 kg of water at 100 degrees Celsius, then how much heat will be required? So if you will observe that one from the steam table, that is the standard condition. In this case, HFG value will be the your 2257 kilojoule. Okay, so this much amount of energy will be utilized. So above it is MA H minus HF1. By using this formula, you can find out what is the equivalent evaporation. Okay. So at the given pressure and temperature condition, you can find this individual parameter. Then by writing this equation, you can find out what is the equivalent evaporation. So next one is the factor of evaporation. So factor of evaporation means in this case we can expressed in terms of the Fe. So Fe is equal to, that is the H minus HF1 upon your 2257. Okay, so the ratio of heat received by the 1 kg of water under given working condition to that received of 1 kg of water, the how much amount of energy is utilized to convert 1 kg of water into the steam at the 100 degrees Celsius. That is the factor of evaporation. So in this case, Ma is taken at 1 kg. Okay. So that is a factor of evaporation. Then we are going to discuss the boiler efficiency. So boiler efficiency, it is the performance parameter of the boiler. So it is represented as a ratio, and that is the ratio of the heat actually utilized in the sorry. Okay, so boiler efficiency is, it is the ratio of heat actually fuel. Okay, so heat supplied by the fuel can be represented as, that is the C. Okay, here let me write down C, or let me write down like this: Ma H minus HF1 upon C. So C is mf into calorific value of the fuel. So this is the heat input, heat supplied by the fuel. So that can be find out by using this formula. So Ma, all of you know that it is the mass of water actually evaporated into the steam, or we can say that mass of steam generated at the 100 degrees Celsius. So by using this formula, you can find out the boiler efficiency. So next one is the heat losses. Okay. So while we are discussing the performance of the boiler, in that case also we have to consider these different kind of losses from the boiler, so that your efficiency, it will directly impact upon the efficiency. So there are the different losses we need to calculate, and we have to include in the overall efficiency of the boiler. Okay. So what are the losses in case of the boiler if we are discussing? So first one is the heat lost to the flue gases. Another one is the heat lost due to incomplete combustion. Right? So third one is the heat lost due to your unburned fuel. Fourth one is the convection and radiation losses. Okay, so these are the losses generally occurred in case of the boiler plant. So first one is the heat loss to the flue gases. Okay. So, in case of the flue gases, there are presence of the different types of dry products of the combustion. Okay. So, which we need to include for the calculation of your overall efficiency of the boiler. So, heat loss to the flue gases, or we can say that heat lost through the dry flue gases can be expressed as your Qg. So Qg is equal to your mg Cpg. It is the difference of the Tg minus Ta. So Tg means it is the temperature of the gases or flue gases, and Ta is nothing but it is the temperature of the air which is entering to the combustion chamber or furnace. Okay, so that is the Ta. So mg means it is the mass of dry gases which is going to the atmosphere, or it is also known as the mass of the flue gases. Cpg means it is the specific heat of those gases. So these can, if these values are known, mg, cpg and tg, then we can easily calculate the heat loss through the dry gases or heat loss to the flue gases. Okay. Uh, okay. So there is another term, that is the heat carried away by the steam in flue gases. Gases which can be expressed as Qs. So these are used in the superheater. So Qs is equal to your Ms1 multiplied with Hs1 minus Hf1. Okay, Hs1. So this is the Ms1 means mass of steam formed per kg of fuel burn, and HF1 is nothing but it is the enthalpy of the water at the boiler entrance, or at the boiler house at the given temperature condition. HS1 is, it is the enthalpy of the steam at the gas temperature. Okay, so QG and QS, this we are discussing under the heat loss to the flue gases or heat loss to the dry flue gases. Okay, so next parameter is the heat loss due to the incomplete combustion. Okay, heat loss due to the incomplete combustion. Incomplete combustion means it is the formation of the CO, more formation of the CO instead of CO2. So in this case, there will be the incomplete combustion, or carbon will be not burned completely into the CO2. So more amount of CO formation will be there. So suppose we are discussing 1 kg of carbon can release 101220 kg of heat if it burns to CO. Okay, so suppose it is 1 kg of carbon can, suppose it is complete combustion of CO2. So in that case, that carbon can release about the 33800 kilojoule per kg of heat. Okay, so here also it is kg. Okay, So then we can calculate the heat loss is, it is the difference of 33800 minus it is 10120. Okay, so this is your how much there will have a certain values. So this will be 0, 8, 6, 23 kilojoule per kg. So heat loss or incomplete combustion will give you the this amount of heat going as waste. So this value is given per per kg of carbon or 1 kg of carbon. So if it is 1 kg of carbon, then it will be 23680 kilojoule. So suppose there is both values are given in volume percentage. That is both value means U is also given by the percentage by volume, and CO2 is given by the percentage by volume. There is the one formula is used to find out the heat loss. Heat loss is equal to your CO into C, CO2 plus CO multiplied with 23680. Okay, so this is the formula used where these values are given, carbon values are given in fuel. So we can use this formula to find out the heat loss. Okay, so then the third point is so heat loss due to the unburned fuel can be found out by using the formula Q is equal to your MF1 into C. Okay, so what is MF1? So MF1 is the mass of unburned fuel, unburned fuel per kg of fuel. C is the calorific value, calorific value of fuel. Okay, so using this formula we can find out what is the heat loss due to the unburned fuel. Then last one is known as your convection and radiation losses. Radiation losses. Okay, so convection and radiation losses, so which are generated due to the hot surface of the boiler. So when hot surface of the boiler is exposed to the atmosphere, so there will be the heat loss to the atmosphere by these two processes. One is the convection, another one is the radiation process. So this can be find out by using the formula loss of heat by this convection and radiation process is given by the heat release per kg of fuel burn minus total heat loss by these methods. So that is the latest write down that equation. It is the equation 1, equation 2, equation 3, and it is the equation 4. Heat loss by equation 1, 2, 3, and 4. I'm not writing the whole sentence, so you can write it down by yourself. Okay, so this is the loss of heat which we can find out by the convection and radiation process. This is the formula. Okay. So this is all about your boiler efficiency. Tomorrow, day after tomorrow, I think I'll take one class more. So in that case, I will teach you about the chimney draught system. Okay. So there is the two types of fans are used: induced fan and forced fan. So there, because of that one, how the efficiency of the chimney can be increased, and that draught process also I will explain. And there are certain equations are used to find out that draught efficiency. That one I'll discuss. Okay. Thank you all.
मैम
Thank you, ma'am.
Oh, hello.
मैम ये स्लाइड्स अगर मिल जाती तो मैम आपसे रिक्वेस्ट था.
हाँ हाँ मैं भेज देती हूँ. हाँ, ठीक ठीक.
थैंक यू मैम.
ओके.
Okay, ma'am.